And this is Haribabu from SNS College of Engineering, belongs to Computer Design Department. Now the subject is about basics of electrical and electronics engineering for the second semester first year. Unit 5 topic is about linear digital electronics. In the topic 4 is digital Boolean algebra theorems. Let us see what the theorem has been included in the digital Boolean. Okay, Boolean postulates and laws. Boolean postulates and basic laws that are used in Boolean algebras. Whereas laws will be the use for reduction purpose, for conveying the reducing the information in a short terms. They are useful in minimizing the Boolean function. That is the main purpose. Okay. So Boolean postulate consists the binary number 0 and 1 and Boolean variable x and its complement x bar. That is when x is 1 and x bar will be a 0. Where x is 0 and x bar will be a 1. So we 1. So either Boolean variable or complement of it is known as literal, and four possible logical or operation among these literal and binary number are shown. Similarly, the four possible logical and operation among these literal and binary numbers are shown below. That is x plus 0 will be x and x plus 1 is be 1, where x plus x equal to x and x plus x bar equal to 1. So this notation can be, I can explain in similar terms, okay, where x will be the don't care condition or the value will be 0 or 1, where 0 will be the lowest value and 1 will be the highest value, and x will be the intermediate value. Just think about it, okay, and x plus 0. So when is lower value, it is a higher value, so higher value is x. So x plus 1. So which is higher value? 1 is higher value, so 1 is the output. So x plus x. So we should not think x plus x equal to 2x. Should be a x. Both are same. Okay. So x plus x bar. When x is 0, x bar will be 1. Similarly, the x bar will be 0, x will be 1. So the output will be 1. This is a condition for addition operation. This is logical OR operation. For logical AND operation, x dot 1 is equal to x dot 0 equal to 0, x dot x equal to x, and x dot x bar equal to 0. This will be the logical AND operation. Logical operations, logical OR operations. These are the simple Boolean postulates. We can verify these postulates easily by substituting the Boolean variables with zeros and one. The complement of any Boolean variable is equal to the variable of that itself. That is x bar equal to x. It's not about that. Just see the x double bar is equal to x. That is when x complement of complement is x. Basic law of Boolean algebra. Next is basics of Boolean algebra. Following are the three basic laws of Boolean algebra: commutative law, associative law, distributive law. These are the basic laws. They are commutative law. If any logical operation of two Boolean variables with the same result with respect to the order of those two variables, then the logic operation is said to be commutative. That is, x plus y is equal to y plus x. Similarly, x dot y is equal to y dot x. The logical OR and the logical AND operation of two variables are shown below. Okay. Next is about commutative law. This is about distributive law. So distributive law is our thing about if any logical operation can be distributed to all terms present in Boolean function, then the logical operation is to be distributed. The distribution of logical R and the logical R of these three variables x, y, z are shown below. Example, x dot in that please note that x dot in bracket of y plus z is equal to x dot y plus x dot z. So when we multiply the terms with x dot in bracket of y plus z is equal to x dot y plus x dot z. Similarly, when x plus in bracket of y dot z, the term will be x plus y close bracket dot x plus z. This is the terms condition. Next is about associative law. So if a logical operation of any two Boolean function or variable is performed first, then the same operation is performed when with the remaining variable. Give the same result. Then for the logical operation, we say to be as well. See, let us see x plus in bracket of y plus z is equal to x plus y in bracket close bracket plus z. In that the bracket is missing. Just I am just to have to convey you. In previous distributive law, x dot in bracket of y plus z the term, and similarly the distributive law in next term x plus in bracket of y dot z. Okay. Next is about auxiliary law, x plus in bracket of y plus z. This will be a x plus y, uh, open bracket and close bracket, plus z. Similarly, x dot in bracket of y dot z equal to x dot y, that is open bracket close bracket dot z. This is about the auxiliary distributive laws. So, the theorem of Boolean algebra. The following two theorems are used in Boolean algebra: duality theorem and De Morgan's theorem. Okay, let us see the duality theorem. This theorem states that the dual of the Boolean function is obtained by interchanging the logical AND operator with the logical OR operator with zeros and ones. For every Boolean function, there will be a corresponding Boolean function. Let us make the Boolean equation image. So x plus 0 is equal to x, that is x dot 1 is equal to x. That the term is represented here. And x plus 1 is equal to 1, so x dot 0 equal to 0. So x plus x is equal to x, whereas x dot x equal to x. Similarly, the terms will be represented for your duality functions. Let us go for a Boolean De Morgan's theorem. This theorem is useful in finding the complement of Boolean function. It states that the complement of logical R of at least two Boolean functions is equal to the logical and of complementary variable. De Morgan's theorem, let us see here. X plus y is equal to x plus y, the whole bracket of complement is equal to x complement dot this and y complement. The dual of above function is also written as x dot y, the whole bar, that is complement is equal to x bar plus y bar. Let us conclude the session and later we will discuss about those things. Any more questions we can discuss later. Thank you.